Research like this is why I love chemistry, because even though this is cutting-edge science, you can understand how it works with only a very basic understanding of molecules. Like, I could have used this as an example in class back when I taught high school chemistry. Here's that stretchy gel sandwiched between layers of glass to make a window for this model house. The infrared lamp mimics heat from the sun. As the window warms up, the gel goes from clear to opaque. Researchers at the University of Groningen Researchers at the University of Groningen made this gel, which is a polymer matrix infused with a mixture of water and a deep eutectic solvent. And if you don't know what that is, look for a link to an ACS reactions video about it in the description. The solvent helps keep the water from freezing at low temperatures, but that's not what causes the visual change. That happens thanks to hydroxypropylcellulose, an additive spiked into the gel. At room temperature, HPC easily interacts with its watery environment, and so it hangs out as these long, relaxed strands. As the temperature rises and the molecules vibrate more quickly, its hydrogen bonds with water get weaker. At a certain temperature, HPC shifts from being hydrophilic to hydrophobic, and so the strands crumple up on themselves and form these globules that are big enough to scatter light, which is why the window now looks frosted. And this process is both reversible and completely passive, no energy input required. So this could be a really great option for green buildings. After 10 minutes under the lamp, the gel window kept the temperature inside the model house 9 degrees Celsius lower than a control window with only water inside, which would be impressive on its own. But while most materials designed for this purpose show an optical transition in one direction, this one turns opaque for both hot and cold temperatures. So windows filled with this gel could keep buildings cool during the day and provide privacy at night. How did the scientists who made this get it to work in both directions? Well, they also added lauryl methacrylate, which forms micelles within the gel. Micelles are self-assembling clusters of molecules. At room temperature, those micelles are nano-sized, small enough that light passes straight through. But at low temperatures, these micelles clump together and grow large enough to scatter light, again causing this frosted effect. And I haven't even mentioned yet how smart the design of the gel material itself is. The researchers made a copolymer with both hydrophilic and hydrophobic sections, so it naturally forms a network held together by both hydrogen bonds and hydrophobic interactions. These physical crosslinks can break and reform more easily than chemical bonds, so you can cut all the way through this material and it can heal itself in 24 hours. And the fact that we can use our understanding of molecular interactions to create materials that do exactly what we want is so amazing to me. The full paper on this research is open access, and you can find it in ACS Applied Materials and Interfaces. Happy Earth Week to the chemically curious!